This video is for section 5-2, rational algebraic expressions. Because powers involving negative exponents can be expressed as fractions, operations involving these powers must follow the rules of fractions. One rule is that the denominator can't be zero. If an expression has a variable in the denominator, then you must determine any excluded values of the domain for this variable. Excluded values are also called restricted values. And we encountered this a little bit earlier this year. Here's an example problem. Identify any domain restrictions for this rational expression. Our concern is that the denominator cannot be zero. So we can write that down. T squared minus 16 cannot equal 0. And then figure out what values of t solve this. T squared minus 16 is a difference of squares and can be factored as t plus 4 times t minus 4. Again, we don't want that to be 0. Then solve each factor for t. We find out that t cannot be negative 4 and t cannot be positive 4. Negative 4 and positive 4 are excluded values or restricted values. A real number is called a rational number if and only if it can be represented as a fraction. So on your note page, please put the word fraction on the blank. The numerator of the fraction is an integer, and the denominator is a non-zero integer. Justify why all of the following are rational numbers. Well, based on what we just read, a rational number is any number that can be represented as a fraction. 5½ can be written as a fraction. It's 11 over 2. 0.3 can be written as a fraction. It's 3/10. Negative 4/5 can be written as negative 4 over 5. And the number 7 can be written as 7 over 1. Because it's possible to write all of these as a fraction, they are called rational numbers. A rational algebraic expression is an expression with a polynomial numerator and a polynomial denominator. Here are some examples. Simplify and find any domain restrictions. At first glance, this doesn't look like a fraction, but because of the negative exponent, it is. This is equivalent to 12a divided by the a squared minus 1. Using the theorem from the previous section, that a negative exponent is equivalent to a reciprocal with a positive exponent. To find the domain restrictions, take the denominator and indicate we don't want it to equal 0. Then solve. This factors as a plus 1 times a minus 1, which cannot be 0. We find out that a cannot be negative 1 and a cannot be positive 1. Those are called restricted values. Next example. On the video, there's a little bit missing. There should be a y next to the 20, and on the end it should say plus 25. Let's simplify this, first by factoring the denominator. This is a perfect square trinomial, and it factors into a binomial squared. Inside here is 2y minus 5. Notice in the numerator there's a 2y minus 5, which will cancel one of the 2y minus 5s from the denominator, leaving 1 over 2y minus 5. We also have to find the domain restriction. The denominator 2y minus 5 cannot equal 0. So 2y cannot equal 5, and y cannot equal 5 divided by 2. Let's summarize the lesson. We reviewed how to find restricted values of the domain of a fraction by identifying any numbers for the variable that would make the denominator be a 0. We also reviewed what a rational number is, a number that could be written as a fraction, and discussed rational expressions, which are fractions that have variables in them. These can be simplified by factoring the numerator and denominator and then reducing common factors.